Welcome to the short demonstration where we're going to talk about a basic Brocade support link topology. We're going to focus primarily on some of the configurations required for the internal DNS server, any firewalls in your environment, and if you have deployed in proxy, which is optional. So before we move into those three components, let's just do a brief overview of this topology. You can see in the bottom left-hand corner, you have your SAN environment, your Fabric OS switches, and to the right of that, you'll have one or more gateways. If you have two gateways, they will be clustered together. Essentially, they need to have access to an NTP server and obviously network connectivity to each other. And we'll talk about their DNS requirements coming up. But basically, what will happen is the Fabric OS switches will send a data set to the gateways. The gateways will then process that data set, sanitize it, and then the data that gets sent out to the BSL servers, which you see in the right-hand corner, will go through your firewall environment and then to the BSL servers back to Brocade. The data set is always, at least the transmission of the data set is always initiated from within your environment and sent to the BSL servers. So let's move forward to focus on the internal DNS requirements for a basic BSL topology. In reference to the internal DNS server requirements, you need to have A records for all of your gateways within that DNS server. If you have multiple DNS servers, all of them need to have the appropriate A records. If you have a single gateway deployed, it's a pretty straightforward process. You would just have an A record for that individual gateway, and the switches would then forward on their requests. Basically, they would do DNS requests and it would resolve to the individual gateway and they would send their data to that gateway. If you have multiple gateways in your environment, you need a way to have a round-robining type effect where the switches can then send data to both of the gateways so they can both process individual tasks. So in this case, you can leverage the round-robin capability of a DNS server. You would need to have individual A records for each of the gateways so that they can communicate with each other. And then you would create what's called a common DNS record. And then you would basically have both IPs of both gateways associated with that domain. And then that would be the domain that the switches would try to reach. And then the internal DNS server would then round robin the request to the individual gateways. Now there's another way to handle this. You can have a DNS load balancer. That's optional as well in your environment, where basically you would point the Fabric OS switches to resolve to that load balancer. And then that load balancer would have the internal logic and the IPs of the gateways, and then it would respond back to the Fabric OS switches. Basically, the first request may get gateway 1, and then the second switch request would get gateway 2, for example. So that's another way to round robin and leverage the processing power of all the gateways in your environment. Now let's focus a little bit on firewalls within a BSL environment. You may have multiple firewalls. Obviously, internally for your devices, the SAN switches must have full access to the gateways, but that's internally. Externally, basically, you must configure the enterprise firewall for outbound connections on ports 443, that's for your HTTPS connections, and port 22. These connections always initiate from inside the environment and go out to the BSL servers. So you must configure the TCP ports to allow those following outbound connections. Depending upon how many firewalls in your environment, those are the two port numbers that need to be opened up. Now there are specific requirements for some of the different features of the gateways, but essentially they all leverage those two particular port numbers, and they try to reach the URLs that I show you at the top there, basically the domains of the BSL servers. So for FC Analytics, basically it's going to try to reach the bsnconnect.broadcom.com. That's the full FQDN of the BSL server. For ACC, make sure that you configure a firewall to allow connections to the bsnacc.broadcom.com. That's the full FQDN. And then for DCA and support save functionality, you need to allow again using those particular port numbers to access BSN support.broadcom.com. So essentially, they need to reach those 3 FQDNs externally, and then going through ports 443 and 22. Next, we have the concept of a proxy server. Essentially, instead of the gateways sending the data sets directly through the firewall to the BSL servers, they will make a connection request to the proxy server. And then the proxy server, in turn, will make connections out to the supported URLs, the BSL servers. So essentially, they act like an offload engine. And in some environments, it is required in order that the devices cannot directly go to send data to external servers. They need to run their connections through a proxy server. And so we do support a number of protocols, different types of proxies. We support HTTP, HTTPS, SOCKS 4, SOCKS 4A, SOCKS 5, and SOCKS 5H. So essentially what you'll end up doing is going on the gateway itself and configuring the connections to connect to a particular proxy server with a certain IP and credentials, and then therefore the gateways will know to send their connection requests to the proxy server, who will then in turn forward on those connection requests through the firewall for the different connections, HTTPS or SFTP, to the BSL servers. This is the end of our short demonstration on our basic BSL topology. Hopefully you've learned more about this particular environment and how to set it up. There are more details within the Brocade Education Learning Portal and a lot more classes on how to set up your BSL gateways in a particular environment. Thank you again.